Hello everybody, today's subject is noise protection and acoustics. So acoustics deal with how well you can understand me in this space. That's about reverberation and reflection of sound waves in the space. And the other subject is sound protection. For example, this door here separates my office from this room that I'm standing in. Yeah? So there's a number of factors that determine how well the sound protection from one space to the other will be. One is airtightness. You can see that there are elastic seals around this door here. There's another seal downstairs that you can see it from the side. Another factor is the weight of the door. If it's heavier, the sound protection is going to be better. Third factor would be to have two separate layers, and if possible, in between those layers, sound insulation, like for example some sort of fiberglass mat or so. And yet another factor is if you have two layers, they should be of different thickness to vibrate at a different frequency. Same principle applies to this window. You can see that there is a seal for airtightness. You can see that it's rather heavy. You can also see that we have double glazing, and in between those two glasses there might be a heavier gas to turn this even heavier. And if I close it, you will see the effect. The second effect we are going to talk about is acoustics. And acoustics, you will see that there's a flutter echo in this space. So the sound waves are reverberated from one surface to the other. If they are parallel one to the other and rather slick, small surface, then we are going to have more of this. And if they have a big surface, like for example this plate here, the reverberations might be lower. You can see that all sorts of fabric are dampening. Here my clothes are dampening, although in the totality of this space it's only a small factor which contributes very little. So here's another example of something that is not very good in terms of sound insulation. It's a sliding door. You can see that it's not airtight. If I'm talking on the inside, you will be able to understand what I'm saying, although I'm behind the door. Here I'm in a room where many people have workstations, and we can teach seminars to the students. So as there might be 50 people in this room, we have acoustic panels on the wall, which are only also used for pin-ups. And these plastic absorbing panels at the ceiling, they have to have a big surface as to absorb the sound in the best possible way. And you can see that in this case here, we have less flutter echo from the walls. These acoustic mats are made out of fibers, and you have to imagine the total surface of each fiber contributing to the absorbing effect. So their purpose is to create as much surface as possible. And for example, a glass surface is the exact opposite. It's very slick. The surface is rather small. Another acoustic material, well, it's not very proper, but it's a sort of felt. And you can see that this absorbs the sound of my voice. Here we have a work niche, and you can see that the suspended ceiling has holes in it, and behind the holes there is an acoustic panel for the absorption of sound. The basic problem in acoustics is double sound. If I'm talking here to a student who is sitting here, he is receiving direct sound waves here from my voice, but he also will be receiving reflected sound waves from the wall behind him. So this creates two sounds at a time, which are bad for audibility in the space. What we can do about this is to add absorbing material here in the back, so this will not occur. And to protect the absorbing materials, we might put drywall, gypsum board with holes in it in front of that, so that here sound can get in, but the absorbing material is protected. The same applies to the ceiling, while the wall behind the speaker should be rather flush and very reflective, as to increase the sound volume that arrives at the student that is listening to my conference. So a nice auditorium would be a space where the seating is in form of a stair. Here's the lecturer, so the sound will arrive as direct as possible to the student, and there will be reflection behind as to increase the natural sound volume. And on the other side, we will be trying to absorb on these two surfaces here, as not to create double sound exposure reflecting from behind. So you have been listening to a Flutter Echo. What is this? Flutter Echo is me speaking on one side here, and then the sound being reflected and reflected and reflected over and over. So what we can do about this is to create absorbing surfaces here, or what we could also do is inclined surfaces, so that the waves of the sound waves become longer and longer. So in terms of sound protection, we are speaking of sound transmission from one space where I am to another space where there might be another professor teaching to other students. So these students do not want to hear the voice of this professor. And so there are different measures to improve the sound protection from one space to the other. In a multi-story building like this one, I'm standing in the space here, and sound transmission can occur via the floor. So this is why we have a screed here on top of the floor. It can be transmitted via the ceiling. So this is where suspended ceilings and sound insulation come in, and it can be in the walls, through the walls. And this is why, for example, drywalls are two layers with sound insulation in between. This is to protect against sound transmission from one space to the other on the same level. So what we are trying inside of these elements is acoustic decoupling by introduction of sound protection inside the construction itself. And you will see